Hi everyone, welcome to Focal Academy. See this problem. Here how to find a load resistance which is the maximum average power from the given circuit. So here we are going to find maximum average power which was drawn by a load resistance, that is RL. So RL means load. It indicates it is a pure real number. Now how can you find that RL and maximum average power for the given circuit? So for that, first of all, we need to calculate Thevenin's voltage and Thevenin's resistance. But here the circuit consists of real components, that is capacitor, inductor. So we'll get impedance, that is Thevenin's impedance, that is ZTH. So from this we get RL value. First of all, I am going to find VTH. For finding VTH, remove the load resistance. Just remove this component. Now find the voltage across this. This voltage is called as Thevenin's voltage. Here the voltage is across, remember the voltage across capacitor. This voltage is called as Thevenin's voltage. So by applying voltage divide rule, we will get VTH equal to, so here we want voltage across this impedance. So this impedance by overall impedance into source impedance. So this impedance, that is J20, by overall impedance, that is sum of all the impedance values, that is 40 minus J30 plus J20 into source voltage, that is 150. So from this we get VTH. So this is the voltage drop across inductor. That voltage is called as VTH. So by using calculator, by simplifying this into phasor form, we get VTH, that is equivalent to 72.76 with phase angle 134 degrees. So this is the VTH. In the next step, we are going to find Thevenin's impedance, that is ZTH. So for that, remove load as it is. So there is no load, it is open. Next, if there is voltage source is there, make it as short circuit. Suppose if the current source is there, make it as open circuit. Here voltage source is there, so make it as short circuit. Means there is no voltage here. Now find the impedance. It gives Thevenin's impedance. So here this branch and this branch are parallel. That is, this branch consists of 40 minus J30 ohms. So 40 minus J30 ohms, which are in series. So this is completely branch, that is parallel with inductor impedance, that is J20. It gives Thevenin's impedance. It becomes J20 into 40 minus J30. Next add these two values, that is 40 minus J30 plus J20. So by simplifying this, by using calculator, we will get a value, that is 9.412 plus J 22.35 ohms. This is the Thevenin's impedance. Next step, how can you find load resistance from the Thevenin's impedance? So here load is pure resistance. So from ZTH we will calculate, that is magnitude of Thevenin's impedance, it gives RL. Suppose in the place of RL there is a impedance is there, load impedance is there. So in the place of RL there is load impedance is there. At the time ZL will be conjugate of Thevenin's impedance. This is the formula. So here load is pure resistance. Now apply this formula, that means magnitude of this. So by applying magnitude of this, we will get RL. So RL is equal to magnitude of this, we will get root of 9.412 square plus 22.35 whole square. So by simplifying this, we will get 24.25 ohms. This is the load resistance. Next step is how to find maximum average power. So here load is pure resistance. So at the time apply the formula, that is P max equal to half of current in that load, the magnitude into RL. So this is the maximum average power in load resistance whenever load is pure resistance. So first of all, find the current. Now here how to find current I. So current I is equal to VTH by total impedance, that is ZTH plus RL. Here value we got VTH, that is 72.76 with phase angle 134 degrees. Now substitute here 72.76 with phase angle 134 degrees upon ZTH. So this is the ZTH we got. Now substitute value here, that is 33.66 plus J22.35 after adding with RL. So just I'm adding both values. So RL and this value. So this becomes 33.66 and imaginary part is same, there is no change. It is in a complex number part, so use calculator here. So by using calculator I will get this part in the phasor form, that is 1.8 with phase angle 100.42 degrees amperes. This is the current. Now substitute current and load resistance in the equation. We will get P max equal to half of, so for the current the magnitude is 1.8 square into, and resistance RL we got 24.25. Now substitute the value here, 24.25. So by using calculator or by simplifying this, we get 39.29 watts. So this is the maximum average power. This is the maximum average power. So whenever load is pure resistance. And this is the process of simplification. Thanks for watching. Please subscribe, like, share. Thanks.